All right. Wednesday, on 25th, so 03/25/2026, you're going to have an exit ticket. Write down the topics for this one. It's going to cover up to the composition and solving the cube root equations. So the topics are going to be properties of cube and cube root, then we're going to have the transformation, we're going to have the inverse. We're going to do the inverse today. We already did the properties and the transformation last class. Inverse, and then the solving. Solving we will do tomorrow. We will have the review on Monday. Zero 30th, 2026. We're going to have the review. And on Tuesday, we're going to have the test. And we will wrap it up on Tuesday. We will start Unit 8 on Tuesday. Unit 8 is bigger than this one. That's the rational. And rational plays a very important role moving forward, because when you are going to go to pre-cal, pre-cal is going to start with rational. So that's kind of what you are going to see moving forward in next year. So the better you understand the rational, the better you have a start next year. Okay, let's go ahead and we're going to work on the inverse today. Again, the inverse is the same. We're going to look at the regular function first. So we're going to look at the original function and see how the inverse looks like in the regular graph. So you're going to take the original function, which is the cube function, and we are using all the universal values. So 0, 1, 2, 3, -1, -2, -3, the one that we always use. So give me the values for this one. If I plug in 0 over here, 0 cube is going to be? 0 cube is going to be?
0.
1 cube is going to be? 2 cube?
8.
Wow. 2 cube is going to be?
8.
2 times 2 times 2. 3 cube is going to be?
27.
Not 9. -1 cube.
-1.
Sure?
It's -1. 3.
Just making sure. Because 2 cube was 8, so I was just making sure.
Oh.
Okay, -2 cube?
-8.
All right. -3 cube?
-27.
Okay, let's draw this one in the graph. You draw it by yourself, then check it with me. So 0, 0 is over here. 1, 1. 2, 8. Then 3 is going to be 27. 27 goes up really high, so we cannot draw this one. It's not going to fit in our coordinate. On this side, -1, -1, -2 and -2 and -8. Again, -3 is going to go to -27, which is very, go farther down. So let's connect. Can you close the door, please? I think I have everyone. Oh, no. He's coming. Okay. Sorry. So it's going to look like something like this. That's your original function. We're going to draw the inverse now. To draw the inverse, what do we do when we when we have the inverse from the table? just flip the values. So all the x values are going to be my new y values, and all the y values are going to be my new x values. So we just flip the values. Let's draw the graph again. Let's plug it in. Do it by yourself and then check it with mine. So again, 0, 0, 1, 1, negative 1, negative 1. If you look at this one, the first three values actually doesn't change. It's the same values for the original and for the inverse. Then it changes the values. So I have negative 8, negative 2. So negative 8 and negative 2. And positive 8 and positive 2. So if we connect, it's going to look like something like that. So now you know the inverse, actually technically you are rotating it 180 degree, and that's going to give you the inverse function. All right. I'm more interested in the next one. So over here you are proving whether two functions are given for you, the original function and the inverse is given for you. You have to prove that these two functions are inverse of each other. We did it before for square function, and for the square root function. It's just a continuation of that one. So whenever we do that, you take the original function, in place of x, you substitute the entire inverse, just in place of x. So when I do it exactly this way. I write down the original function, everything stays the same. In place of x, I just put a big parenthesis, and I take the inverse, I just plug it in over there, then simplify. At the end, you're supposed to get x, nothing else. Not negative x, not 2x, not 1, not 0. Only x. And once you get the left side, you're going to do the exact same thing on the right side as well. So you're going to take the inverse. In place of x, you're going to substitute the whole original function and then simplify. Once you get both of them are x, you can say that they are inverse of each other. Now, once you get the left side, don't stop over there. It might happen when you are working on this side, it might not give you the inverse. So always check both sides. Let's work on one problem. It will make more sense. So here the function is given f of x and g of x. F of x is the original, g of x is the inverse. Let me make it a little bigger. All right. I'm using two different colors so it's easy for you to see it. So we're going to do f of g of x. Okay. Let's write down the f function here, which is 8x cubed plus 5. Everything stays the same. In place of x, just put a big parenthesis, and I'm going to take the pink function, which is the inverse, and I'm going to plug it in. Okay? So 8, put a parenthesis, don't forget about the cube on the top, plus 5. We good up to here? Give me a thumbs up. We good? All right. Now let's write this whole function here. So we're going to write down 1/2 cube root x minus 5. Any questions? We good? Whatever you are doing, that needs to stop for a sec and look at the board, please. Please pay attention to the board. Now I have a power over here, which is the cube power. Inside the parentheses, I have a term which is multiplied with each other. When you distribute the power, you forget that you have to distribute it with both of them, not only with the cube root. It's going to go with 1/2. Also, it's going to go with cube root because they are multiplication with each other. So, if anything happens like that, that you are having multiplication of 2 or 3 terms side by side, if you distribute any power, it goes with all of them. So this power is going to go over here, also over here. We can separate. What's the value? 1/2 cube? 1/8. So inside the parentheses, we're going to have 1/8. And what happens over here?
You just get rid of the cube root.
So x minus 5. Correct? And then plus 5. Any confusion over here? Anybody have any confusion? Okay. Now this is the PEMDAS, so we have to multiply the 8 with it. Can I simplify? Do anything to it? 8 and 8 are 1/8, so they are going to be cancelled out. So I have x minus 5 plus 5. Can I simplify? Is there a like term? Anything? What happens?
It's just X.
It's just x. If you look at the color of this function, I have the pink x. It means this x is coming from this function. That's why I'm using different color. Just to give you an idea, you don't have to use two colors. I'm just showing that whenever you are substituting, actually after substitution, this x is left from this function. It means it's saying that when you are substituting everything, you are cancelling everything, only the x is left from this function. So this side is proved. We have to do the exact same thing on the other side as well. So I'm going to take this function, and inside it's going to be the f function. Now let's write down the g function here. 1/2 cube root of x minus 5. In place of x, I'm going to put a big parenthesis and I'm going to substitute the original function over there. So let's do that one. 1/2 cube root, in place of x, keep a parenthesis, minus 5. 5 is under the radical loop. So now, over here, I'm going to plug in the original function, which is 8x cubed plus 5. It's the PEMDAS, so we have to do the parentheses first. So if you look at the PEMDAS, PEMDAS, parentheses, then exponent. So we have to get rid of parentheses first, then apply the exponent on top of it. All right? Go by the PEMDAS rule. So we're going to simplify 8x cubed plus 5 minus 5. Can I simplify? What happens?
Then you get 8x.
8x cubed now that's again a multiplication. I'm applying the exponent. So both of them are going to have it, right? Both numbers. 8 is going to have it. Also x cubed is going to have it. I can separate them. So let's write it down. Cube root 8. Cube root x cubed. How can I simplify this? 2 cube is 8. So I can write it down. And this one will be, they're going to cancel each other. It's going to become x. Also, this cube and cube root, they're going to cancel each other. So I have 1/2 times 2 times x. Can I simplify anymore? So this cancels each other. It's going to give me an x. So in both cases, I'm getting x. It means they are inverse of each other. Any questions? Confusions anywhere? We good? Do number 2. I'm giving you 6 minutes. It should not take that long, but still I'm giving you that time. Do number 2. Once you are done, raise your hand. I'm gonna check it, and then you're gonna go to your practice paper. But first, do number 2. Go to your practice paper. Go to day 2. So it's gonna be composition of functions to prove inverse. So this and this page. First, do number 2. Show me. I can check it, and then we're gonna do these 2 pages. Any questions? We good? All right, go ahead.